Alright, welcome. Today in this video we're going to be discussing integrated ISIS or intermediate system to intermediate system. So ISIS is the other link state routing protocol. You may have heard of this term back in your CCNA days, but you don't get into the configurations till you start studying for CCIE or possibly even the service provider certification track. So ISIS, it's very similar to OSPF. So if you learned OSPF and kind of mastered that, learning ISIS should be pretty simple because they do have a lot of similarities, but ISIS was made for the OSI protocols. Um, so it does things a little bit differently. So I'm going to go over the configuration and how this works and how it differs and why you would want to use ISIS. So in my readings, I've learned that ISIS is a link state routing protocol, again, open standard, but why do you want to use it? Well, service provider networks would probably want to use link state routing protocols because it isn't an open standard and you do not have to follow the rules of OSPF, where you have area 0, which is your backbone, and then all other areas have to connect to it. And if you don't, then you have to do things like virtual links, which aren't permanent solutions. So ISIS still holds the topology, still holds a database of all the networks, and the backbone now, it doesn't have to deal with areas. Notice here in my topology, I don't have area 0. The way that the backbone works in ISIS is these level 2 routers. Level 2 holds all the routes to the entire topology. Level 1 routers, they just hold the routes for its entire area. That's it. So area 1, or actually level 1, area 1 router has no idea what the routes look like in area 2. Only the level 2 routers have the full picture of it. So I'll explain all of that when I configure it. I'm going to be configuring router 8, 9, and 10. So uh, the way adjacencies work, it's not really as strict as OSPF is. So adjacencies, they're only based on matching levels. So only a level 2 router can make an adjacency with another level 2. And notice here, some routers could be both level 1 and level 2. So if I didn't have this level 2 router right here, and let's say he was gone and I just had a link between this level 2 and level 1 router, they would not form an adjacency. So to bridge that, you have to have a level 1 dash or slash level 2 router in between it to be the middleman. Okay? The hello and hold timers, they're 10 seconds and 30 seconds for the hold timer. They don't have to match, just like EIGRP, they don't need to match, but in OSPF they do. So that's a difference. There is no router ID. Like in OSPF, you have to name or give it a router ID, and that's in the format of an IP address. But it isn't an IP address. It's just a number in the format of it. In ISIS, we have to give it a network service access point address, which is called an NSAP. And I'll explain that once I configure it. And by default, every interface, regardless if it's a fast 100 megabit link, a gig link, 10 gig link, ISIS is only going, by default, is going to give a metric or cost of 10 for every single interface right here. So so if you step back and think about it, this is almost like a distance vector protocol like RIP. So if we don't change the metric 10, 10, 10, 10, it's just going to choose basically the lowest amount of hops because every metric is 10. So this is where the administrator would need to go in and say, all right, we could follow the rules of OSPF where you can do the 100 megabits over the X amount of bandwidth or whatever you want, but you do need to do a little bit of more configurations because you need to go into every interface and say, all right, fast Ethernet, you'll have a cost of, let's say, 100 because we have gig links. So let's say gig links will be cost of 10 or 1. Doesn't really matter. The narrow metric for ISIS is 0 to 63, I believe. I believe that's the number for the narrow metric. I'll have to get back to you on that. But, anyways, let's go and configure ISIS. So we'll start with router 10, which actually I think it's up already. Here it is. Bring it into screen. And IP addresses are already configured. So config t router ISIS and then hit question mark. I could hit enter right now, but we can give it it says an area tag, which is locally significant. So I'm just gonna say 10. Okay. Now we have to give it this nsap address, so it starts with net, and this is almost like BGP, where this first portion, this 49, it's given to you by the ISO. But since this isn't routed on the internet, 49 is pretty much like a private autonomous system number, just like BGP has private autonomous systems number. So 49, cool, we'll do that. Now the next portion, this is the area ID. So 49 dot and then whatever the area is, so 0004. Now on Cisco routers, this next portion, which is called the system ID, I believe, the system ID, this is where it has to be unique for this area. So doesn't really matter, you could name it whatever the MAC address is, but since this is router 10, I'm just going to say 10, 10, 10. And this has to be 6 bytes. So on Cisco routers, it has to be 6 bytes for this section. And then the last part is 0. It has to be 0. That's the network entity title at the end. The end selector. I believe that's what it is. Yeah. Yeah. Cell ID. Cell. Anyways, but it has to be 0. So I hit enter. Bam. Now let's log adjacency changes, and we have to tell this router that it's going to be a level 1 router. So we say IS type. It is IS type. And then we could say you're going to be a level 1, level 2, or level 2 only. So we are going to be a level 1. There you go. Now there is no network command in ISIS. You actually have to go into the interfaces and tell it to enable ISIS on that. I actually like this process better because I don't have to mess with the network command. Whenever I try to teach my students it's confusing, and I'm just like, just go into the interface and just enable it. So we will do IP router ISIS, and then whatever the process was, which we said was 10. And then we'll enable it on the loopback as well. And that should be it. We'll end. And then let's configure router 9. So we're going to do the same type of process there. So I'm going to do it a little bit quicker. Config T router ISIS 9 net 49.0004 9999999900 log adjacency changes. By default, it's a level 1, level 2, so I don't need to mess with that. And let's go into the interfaces and enable it. IP router ISIS 9. Interface loopback 1. Enter. We should get an adjacency. Good. I'm going to stop right there for a sec. And I want to see what router 10 sees in its routing table. Okay? So let's pull up router 10. Now that we got an adjacency, we should be getting ISIS routes. But guess what? Since this is only level 1, we should only see level 1 routes, because it's not level 2. So let's do show IP route ISIS. And we have a 9 network and an 89, which is this network right here. And then 9 is the loopback. And Let's actually do a show IP route. And one thing that I want to show you, since I don't have a level 2 adjacency with router 8 yet, basically we're only running inter or intra area routes. So notice here that to get out of this area or level 1, I don't have a default route. Now once I enable level 2 services on router 8, router 9 will say, hey, I'm a level 1, level 2 guy. I have a level 2 adjacency, so if you want to get out of area 4, here's a default route. So let me go and configure that on router 8. Config T, router ISIS 8, network 49, 0004, 8888, 8888, 8888, 00, log adjacency changes, IS type, level 2 only, interface F0/1, IP router ISIS 8, back 1, 0/0, 8, interface F0/1, 8, end. Okay, so now we got all of our adjacencies. We should have about 3 adjacencies, 1, 2, and 3. And now let's see if router 10 has a default route to get out of its network. It should. And right there, there we go. So what this static route shows, well, one, he learned it via ISIS. But he's saying, all right, well, router 9 has more information than me, so instead of giving you the whole topology, because level 1 routers don't need to know about it, that I'll just push you a default route, and if you want to get out, to just give it to me. Now this is kind of bad because since it doesn't have a full picture of the network, it's just going to send its packets, its data, to the closest level 2 router. Now that doesn't necessarily mean that that is the best route. So again, it's almost like giving out 2 default routes with ABRs in OSPF. Only those non-ABRs in an area for OSPF, they're going to send it to the closest ABR. So this is like the same concept here. So let's take, so this is the only thing that router 10 knows about, is level 1 area 4 routes, and it has a default route. So if I were to ping the loopback of R1, which is right there, and I'll source it from my loopback, which is 10.10.10.10, we have connectivity. Sweet. And since R1 is the same type of router, it's a level 1, but in a different area, again, if we do a show IP route, it has a default route to get to 10.10.10.10. But let's look at the routing table for router 8. Show IP route. Let's expand this. And look at all of these routes. So level 2 routers, they are the backbone, and they have the whole entire picture of the topology. And this is where they'll send out like level 1 LSPs and level 2 LSPs. I'm not going to get into that, but a ISIS router will only send out 1 or 2 type of LS link state packets, where, you know, OSPF will send out type 1, type 2s, type 4s, type 5s, type 7s. ISIS, they only send out level 1 LSPs or level 2 LSPs, or both if they are doing both. All right. Let's see, one other command that you can do is show ISIS database. And this is just showing you the database of ISIS, just like show IP OSPF database. show ISIS database is the same thing. So, um, and if we look here in the routing table, that everything is a multiple of 10 because by default, everyone's interface is a cost of 10. Now, if you want to change that, well, let's go to router 9 and change it on the interface. You have to do it on the interface level. Interface F0/0, and we'll say ISIS metric, and we'll say a metric of 1. And so let's slide over to router 8, and let's do a show IP route to the 10 network, which is on router 10.0. And look at that metric. Metric is a 1. So that means that we change this one to a 1 here. So I guess it probably used to be. Where's the 10 network here? Did I not have it? There it is. It used to be of 30. Now when I change that metric on router 9, now it's 21. There you go. You can also see the metric there. So, and of course the administrative distance on a Cisco router for ISIS is 115, OSPF is 110, RIP is 120, EIGRP is 90, so on and so forth. Okay? So I hope this gave you a little bit of better understanding of ISIS and how it could be implemented. It's pretty simple, I think, but you just have to get used to this whole NSAP address and level 2 and level 1s. But you would see this in service provider networks because they don't have to follow the rules of OSPF and Area 0 because the backbone now is level 2 routers. That's the key. So I hope this was informative for you, and I'd like to thank you for viewing.